Alright, so here we are with our Chapter 3, Section 1, first set of notes. So Chapter 3, woo. First thing that we're going to talk about are linear equations, and so that's going to feel a little bit like we're doing algebra, but again, algebra is within geometry, so that we keep practicing it in order to use it in Algebra 2, and not to mention just in general. Alright, so first thing we're going to talk about is slope-intercept form. So the idea is that generally what you are accustomed to is slope-intercept form, and so you see this nice slope here and a y-intercept, yay! But there is actually something called standard form, and so that's up here as having both the variables on the same side. So that's what they mean by standard, is all the variables are on one side. Super. So our first example here is going to be writing from standard form, which it already is, see x and y are on the same side, into slope-intercept form. So this is where we take those ideas from Algebra 1 so that we can rewrite this as y equals. Okay, first of all, this is going to be helpful when we're trying to recognize what the slope of something is, or the intercept, or being able to graph it, as we have already done. And so, in order to do that, you are always going to find the x value, identify if it's positive or negative, in this case positive, and then we're going to move that entire item, so 2x, whoa, that was my hand touching the iPad, 2x over to the other side. So, as much as you want 6 minus 2x to give you 4x or something, it really is actually just going to get you negative 2x plus 6, because this is a positive 6. You do want to take the time to rewrite so that the x is first and then the number. Otherwise, you're going to end up with something that's not recognizable in our format that we know. So notice x is usually first and then the number. All right. So then the next piece is the fact that negative 3 is being multiplied by y, because again, we're trying to get y all by itself. So if that 3 is there, it's preventing it from being just a y. So I'm going to take the fact that that's multiplying by 3 and now divide by 3. The problem with that is that you must divide every piece, every term over here by negative 3 as well. And so officially, the negative 2 and the negative 3 becomes positive 2/3 with an x, and then the 6 and the negative 3 become negative 2. And so here is our slope-intercept format from the standard format. All right. So being able to rearrange those is going to be very helpful. The next piece is trying to get slope from 2 points. Again, I know that you have been presented with this before, but if you are ever given an x and a y point and another xy point, in order to find the slope, you're going to do the change in the y's on top, meaning subtraction of the y's, and then the subtraction of the x's on the bottom. You do want to make sure that you remember that it's y's on top, x's on bottom. Otherwise, you're going to end up with what we would call the inverse of your slope, which is not very helpful. All right. So, first thing that I do, especially since I use this formula, is label each of these as x's and y's, and then as either being from the first point or the second point. So now I know that if I want to fill in this formula of m equals y2 minus y1, x2 minus x1, all I would need to do is erase my y2 and actually fill it in with, in this case, 7. And then take away my y1 and replace it with negative 2. The reason that I do this is because notice that you can see that there is actually a negative from the formula, but then also a negative from the number. And what happens a lot of times is that you will just assume one negative is two negatives, and so you'll just keep it subtracting. But in fact, subtracting a negative is positive. So then we have x2, so the one from the second point is negative 5, and then we have x1 that can be replaced with 4. So if we simplify, 7 plus 2 is going to be 9, and negative 5 minus 4 is negative 9, and then that simplifies to negative 1. So negative 1 is the slope between the 2 points. Alright, then we're supposed to graph the linear equation, and so if we graph a linear equation given our y-intercept and a slope, becomes very easy. You can also graph via the equation. So you can identify the slope and the intercept and graph that way. And you can always graph from a table. No matter what the item is, you can always end up just making a table of values and plot them out. So, at least the way that I believe this is easiest to do is to identify the slope. So in here we have a slope of -4/5. Officially, if the slope is -4/5, if you put that negative on top, that means that from a point that you start at, you're going to go down 4 and then right 5. The point that you start with is called the y-intercept. And so that actually means that the point 0, 8 is where you start, and then you're going to go down 4, right 5 from that point. So if I grab a piece of graph paper here, let's see. Ooh, I'll want it with lines. Okay. The first thing that I'm going to do, again, I'm graphing -4/5 x plus 8. I'm going to start at my 8 as my y-intercept, so 1, 2, 3, 4, 5, 6, 7, 8 up here. And then from there I'm going to go down 4 squares over 5. So down 4 squares over 5, 1, 2, 3, 4, 5 is my next point. Down 4 over 5 is my next point. And next point. So this is the equation graphed of y equals -4/5 x plus 8. Reason that we're going to need to know this is because eventually we'll start making things like rectangles off of this, and then we'll talk about the sides of the slope of that rectangle. Lots of fun stuff, but we need to remember those pieces before we can actually get to our geometry involved. All right. Okay. So then the next piece here is to find an equation from 2 points. So this one's a little bit more involved because the idea is that you can use point-slope equation, or you can actually use the slope-intercept equation in order to find out what the line is that would go between 4, -1, and in this case, -2, 8. So there are 2 ways that you can do that, but either way you're still going to have to start with finding the slope. So again, your slope is your y's subtracted and your x's subtracted. And so going through, I have my x and y for the point 1 and my x and y for the second point. And so I'm going to put each of those pieces in. So the first piece I'll put in is y2, which is 8. And then the second piece is y1, which is -1. Then we have x2, which is -2, and x1, which is 4. So simplifying that, we're going to actually have 8 plus 1, so 9, and -2 minus 4, so -6, which means if we divide by 3, our slope is -3/2. And as much as you want to make that into 1.5, you want to keep it as a fraction when you are graphing, at least. All right, so the next piece is either using this point-slope equation or using the slope-intercept equation. And since I don't want you to have to memorize another equation, it might be best to just use the one we already know. So what we're going to do is we're going to fill in our y1 and our x1. You could do y2 and x2 if you wanted to. And then we're going to fill in our slope. And notice that that will leave us with just the b, which is what we need to solve. So if we go through and solve this, that means that my y1 is going to be replaced with a -1. My slope is going to be replaced with -3/2. That's going to be multiplied by my x1, which is 4. And then we're going to add b to that. So in order to simplify, I'm going to take -3/2 and multiply by 4. Technically, a little side note here, -3/2 times 4 is multiplying across the top, which is -12, and multiplying across the bottom, which is 2. And so officially it's -6 for this result. Got to watch out for this part at the end here because my b's look like 6's, so I thought that was -1 equals -6 plus 6, so that's not a thing. All right, and then in order to get b all by itself, we're going to add 6 and realize that b is 5. So since we know b is 5 and m is this, our equation for y equals mx plus b is going to be y equals -3/2 x plus 5. So as you do in the previous problems, you need to find slope, okay? And then from there, you can insert your slope and your first point and end up with your b value. Again, if you use this other equation, that's perfectly acceptable as well, but the idea is that you could get your intercept or your equation of this without necessarily having to use a different equation. All right, the last idea that we're going to go over is parallel and perpendicular lines. So with parallel and perpendicular lines have the same slope. Okay, so if you ever see a line, for instance, that is parallel to this equation here, it will have this same -3/2 slope. All right. Perpendicular lines have opposite and reciprocal slopes. Okay, so if we ever see, for instance, this slope here, so I'm just going to write the previous statement, parallel to -3/2 is 3/2, sorry, -3/2, but perpendicular to -3/2 is going to be the opposite, which means in this case a plus, and then the reciprocal, which in this case means flip, and so the perpendicular slope is going to be positive 2/3. So you flip it and you make it either negative if it's positive or positive if it's negative. So taking a look at our example, we're going to write an equation in slope-intercept form for the line that passes through this point here and is perpendicular to the line that is described here. So that means that your point of x1, y1 is 4, -2, and your slope used to be related to -4. So think of -4 over 1. But if we want the perpendicular slope to that, we're going to need to do positive and then the flip, 1/4. So your slope is 1/4. Which means if you want the equation of the line that passes through this, we need to take each of these pieces. So this is our x, and this is our y, and this is our slope. And we need to plug them in just as we did in the previous problem into the equation to find our b, and then therefore find our equation. So we're going to put it into y equals mx plus b in order to find b. The y value is actually -2. The slope is positive 1/4. And the x value is 4. So in order to solve that, a 4th and 4 are going to make 1 when you multiply them. So -2 is going to equal 1 plus b. But if we subtract our 1, we end up with a b of -3. So now we know our slope is 1/4 and our b is -3, which means that our equation is y equals 1/4 x minus 3. Please do not insert the y value of -2 and the x value of 4 into the equation, because that is no longer an equation, it's just a statement. So we need an equation, and equations have a y and an x when it comes to linear equations. All right, so those are our notes, and in your assignment you are in fact going to have parallel and perpendicular lines to write. You're going to have to find slopes. It's going to be a little bit of review from linear equations in Algebra 1.